So where we're going now is um, chapter 7 in the book, and I kind of have it here. I pulled out the different, so notice I just pulled out chapter 7. Eventually, at some point today, you're going to need something called a Z table. And just for today, I posted it on Blackboard. So eventually you're going to need that. And eventually there's a handout that we're going to need that I also posted on Blackboard. So it should be in this week's folder. It says hypothesis testing. So I'm going to introduce this notion that is going to be hopefully review for you. But if not, I think it'll bring us. So this is starting now. This was going to be on exam 1, but this is not going to be on the final. So I'm going to write this here. Hypothesis testing. Okay. You may remember this in your 222 class or whenever you took stat. All right. And we'll just begin just kind of by talking about what a hypothesis is. Like when you were like in high school, what's the age-old definition for a hypothesis? Like what is hypothesis? Like when you're in high school, like 9th grade, 10th grade, it's almost a universal
when you
definition.
when you project what's going to happen, type of thing.
Good. Yeah. You know, you hear people say an educated guess, right, or prediction. Yeah, very good. And so, although we may do that in stat, I'm going to give us now the college definition for it. So some guessing may occur or some prediction may occur, but in terms of statistics, we're going to define a hypothesis. I'm going to say DEF, and that just means definition. We're going to say a hypothesis is not necessarily going to be an educated guess, but it's going to say is a claim, CLAIM, that is put forth. Okay? It's a claim that is put forth. I guess it could be a guess, I don't know. But we're just going to say it's a claim. Like, let's say Raisin Bran, when they package their cereal, used to be when I was coming up, you look at a commercial and they say there are 2 scoops of raisins in every box. I don't know that, you know, but that's their claim, right? And it has to do with a claim generally that says the average something is something, right? Like it just can't be like just some claim, you know, I claim these apartments are nice or something like that. It has to do something with math, and often the average something, that's the case. And so I'm going to say in general, comma, we refer to it as the null, NULL, hypothesis. We refer to it as the null hypothesis, or H sub 0. Okay, that's an H and then the little number 0. Sometimes it's called H naught, NOUGHT, which is another word for 0. But null is what is the original claim. May or may not be right, but at least I'm claiming it, right? So we have this null hypothesis here. And I'm going to say definition. So what is kind of setting up the backdrop for doing hypothesis tests. We're going to say the alternative hypothesis is the opposite of the null. Hypothesis. Let's say we write it as H sub 1. So that's H there and then a little 1 there on the bottom. So I'm going to say alternative hypothesis. All right. And so when we get into hypothesis testing, I'm going to write this one last definition here. It's going to end up being like a mathematical boxing match. You want to think of it that way. And so let's write this last definition so we can try to bring some sense to this. So then what I'm going to say is a hypothesis test is a test, okay? A hypothesis test is a test designed to prove or disprove your null hypothesis, or H sub 0. So everything we're going to talk about today has this in mind. So we define what a hypothesis is, a claim that is put forth by somebody, right? And it becomes a boxing match because if you watch boxing or whatever other, well, in this corner we have such and such and such, and then in that corner we have such and such and such, right? And it's H sub 0 versus H sub 1, and you have to do something mathematically to see who wins the boxing match, right? So you have H sub 1, which is the null, H sub 0, which is the null, H sub 1, which is the challenger, right? And they're going head to head, and at the end of the day, there's going to be a winner and a loser, okay? And we got to use some kind of mathematical or statistical techniques to help us determine who is going to win. It'll never be a draw. It'll never be like, it'll never be something where there's not a winner. There's always going to be a winner, okay? So just, and I know this kind of seems like kind of out there, but I want to give the general structure or framework for hypothesis testing in terms of definitions and where the stuff comes from. All right, now in terms of notation, let's do this. I don't have the regular size board, but we'll make do. Now in terms of notation, there's going to be certain notation we're going to be comfortable with. Like I'm going to write this, we'll say notation. I'm going to say at some point we're going to need something called X bar. So let's say X bar we're going to call, we'll say is the sample average. What do I mean by that? Let's say I want to do a test of like, I don't know, the average prices of homes in the area. Let's say like in the community that I go into, it's like 200 homes. Well, I'm not knocking on 200 doors, right? That's everybody. That's like all the houses. Well, if I want to just figure out, let's just do 30 homes, right? So I just casually sort of go and do 30 homes, and I get those 30 homes, and I take that average. That's what I'm calling X bar. It's an average, but it's an average of hand picking, right? Just kind of getting you guys heard of sample before. Whereas another symbol that we have is the population average. If I literally were to go house by house by house by house, get all 200 of them, and then take that average. Anybody know what that symbol is? I want to see what you know. What's the population average? What is that called? X bar is the sample average, whereas what Greek letter represents the average of everything? Everything.
Is it the thing that looks kind of like a Y?
Yep, yep, exactly. In fact, it's called, looks like this, mu.
Yeah, that's what I meant.
Very good, very good. Yeah, it has like a little extension there, right? And it's pronounced MYU, mu. Kind of like what a British cow would say, I guess. Mu, MYU. All right. All right. So yeah, so we have the mu. That's the population average. X bar is the sample average. Okay, so that's good. We're getting there. And one thing we're going to find out about hypothesis testing is the power of it is I'm going to be able to use information from the sample, like those 30 houses, to reach a conclusion or draw a conclusion about all of the houses. See that? See that? Now, if I'm only concerned about all the houses, like somebody came and knocked on my door about 3 days ago, and I was like, who is this? And I opened the door, and it was one of those wonderful census takers, right? You know, they do census every 10 years. And, you know, I had to tell her, well, I figured this out already when I used to live in the Bronx and all this kind of stuff. So I moved, and they just didn't know or whatever. But that census is trying to get at all 200 homes. They don't want to. But the power of the sample or the power of hypothesis testing is that statistically, I can use information from a sample like X bar, right? And then draw a conclusion about mu, all of the homes there. Well, clearly, what's the benefit of that? Well, number one, it's going to save me time. Who has time to go around to 200 homes? I don't. Number two, depending on what the test is, it's going to save you money, right? It's just that this X bar has to meet certain requirements. Like it has to be big enough, right? Like I can't just go to 3 homes and say, oh, I got information about 3 homes. Now I'm going to draw a conclusion about all 200 of them. I mean, I guess I could do that, but the larger the size of my sample is, kind of the better. Okay. So these are the symbols that we're going to have to kind of think about it. And so why don't we write this? I want to make sure we go slow. Let's say note. Let's say the power of hypothesis testing. Kind of summarize what I just said. The power of hypothesis testing is that we can use information from the sample to make a decision about the population. Okay? So that's kind of the overarching framework mentally. The power of hypothesis testing is that we can use information from the sample to make a decision about the population. And so that's good. That's good. Now, there are some other symbols we are going to have to need eventually. So let me write those up here. I'm not going to get too much into them, but just so that we'll know how to fashion this, I'm going to write this thing right here. It looks really weird. It's like a little loop thingy, and it sort of goes around there, called sigma. We're going to call this, we're going to say is the standard deviation of the population. So it's sigma, it's like a little swirl thingy going across there. That's called the standard deviation of the population. Now, just in general, just a general idea about what standard deviation is, it's just like it gives a sense of how spread out the data are. So let's say if I want these houses, these 200 houses, now remember, this is dealing with the population. So this is like all 200 houses. Let's say, for example, I went house to house, and I found out that the salary that people earned in all of those houses, I know this is not going to make sense, but let's say I went to this one house, the people here make $50,000. Go to the next house, $50,000. The next house, now I know it's not real, but let's imagine that were the case. Everybody in the home made $50,000 in all 200 of those homes. Then the standard deviation in that case would be 0 because the data are not spread out. It's not 50,000, 60,000, 70,000. It's literally 50,000, 50,000, 50,000, 50,000, 50,000. Well, it's the same data, so that data relative sort of like to the mean is not spread out. It's literally the exact same number. So in that case, sigma equals 0. There is no spread. There is no spread. Okay? So that's just a general sense. I'm not going to delve too much into that. And then S, so we have X bar, mu, sigma, and then S. S is the standard deviation of the sample. Okay, so we got two things going on here. We have this large circle, which is the population. Then we have the smaller circle, which is a sample out of that population. Yes? And so when you're looking at the entire population, like all 200 homes, right? You take that average, that's mu, and you take that standard deviation, that's sigma, right? In other words, this mu here, you take all the numbers here that you get from whatever you're studying out of everybody, add them all together, and divide by, in the house's case, like 200, right? That's the average of all of them. And the standard deviation is just simply saying, well, we have a real complicated formula for it. In this course, I will never ask you to calculate the standard deviation. Like I can give you some data and say, calculate the standard deviation. Well, not in this course. We don't have time to, that's in your 222 course. But just make sure you can at least understand what sigma means conceptually. It's just a general idea of how spread out your data are. Okay, so this is the population right here. And this is the sample. This is like I take a few of those out of the population. I take that average, that's what we're saying is X bar. And when I look at, let's say if I look at 30 homes and I look at the spread of just those 30 points, that's what I'm calling S. So mu is to the population what X bar is to the sample. Sigma to the population is what S is to the sample. So the sample is like a mini little population. Okay? Is everybody okay with that so far, just in general? I know we haven't really done anything per se, but I want to make sure we can at least understand just these symbols. And if you think about it, watch this. Okay, so this is coming totally from left field. This is going to convince you why hypothesis testing makes sense. Because you do it already, even without realizing that you do it. Can anybody in here cook? For example, does anybody in here know how to make soup? Yeah. Okay, good. Okay. What kind of soup can you guys make?
Chicken soup.
Huh?
Chicken soup.
Chicken soup? Okay. Good. Anybody else? Now, we're not talking about, little chunky stuff you get and just pour it in the thing. I mean, like, can you make soup, like from scratch? Oh, lentil? Oh, okay, good. Nice. I love lentil soup. Imagine this. Imagine having a humongous pot of soup. Let's say we want to feed the whole class, right? So that's a pretty big container, right? How do you determine if it's seasoned correctly? Like, you put all the stuff in there, you do all this, you do all that, you do all that, and let's say it's quote unquote done. How do you test to see if it needs more salt, more pepper, more whatever you put in there? Okay, you taste it. But how do you taste it? What do you do? Yeah, good. Good. So what you do, you kind of take like this big stirrer. Just imagine you're working in a cafeteria. You take this big stirrer, you make sure everything is kind of all stirred up. And then you generally, I have my coffee right here. You generally take like a cup or whatever, I don't know. Depending on how ghetto you are, you know, you can actually take this cup and like literally dip it inside instead of have it pouring down your arm or whatever, right? But you generally put some inside of a cup, right? And yeah, there you go, Lydia. You do this and you taste what's inside of here. Why? Because hopefully, once you sort of like what's in this big pot, if you stir it correctly, is pretty much inside of here, right? And so now you do this. Ah, perfect. Or nah, needs more salt. And what you determine from here, you make a decision on, you know, in the whole pot. Like, I don't take the whole pot and do this, drink it until it's gone, and say, yeah, that needed some more salt. That wasn't really good. Well, it's gone. It's gone. Right? And now you got to start all over. So the whole idea is you take a sample, what's inside of here, you're making a decision on the sample that's going to affect the entire pot. You guys see that just in general? You see that the kind of parallel? Okay, so that's all that hypothesis testing is saying to do. You're going to make a decision on the sample, and then you're going to make a conclusion on the entire population. Okay? So now let's get into some numbers. So I think you guys understand the general flow of this thing here.